All right, you guys, let's hope this video goes better than the first one with my new computer. So write the piecewise function from the graph below. So the reason we have piecewise functions is because we have two very specific graphs in one function. So of course we're going to write, if we just do f of x equals, and then we're just going to write two different ones. So one for, oh, that didn't give me a highlighter, did it? Ugh. Well, we're just going to keep going. One for that piece of the function and one for this part of the function over here. Okay. So the first one, they're both going to be linear, so we're going to have two that are like y equals mx plus b, right? So always start with the reading from left to right. So we're going to start with this negative slope here, and we can just look at it and find the slope. Whoops, look, happened again. We can find the slope just by doing an up, like an up and over, right? The rise over the run. So I feel like the rise is 2 and the run is 1 right there. And it's a negative slope. So just don't forget that this line is negative. So our first one is going to be negative 2x, and then the y-intercept is right here where it crosses the y-axis at -1. So -1. Gosh, so hard not to cuss, and I know I'm on this video. -1. Okay, and then we have to put for what domain. Oh my god, we have to put for what domain that is. Let's see if this works again. So we have to put for what domain that is, and that is where x is less than or equal to, whoops, not equal to because it has an open circle, where x is less than 1, right? Because it goes to the 1 and it's an open circle, okay? The other one looks like it's going to be up to over 2, which is just the same as a 1-to-1, right? So my slope is going to be 1x. Son of a gun. I'll have to figure out how to do this better next time for you guys. So it looks like it's going to be 1x, or just x. We're being babies here. And the y-intercept, we have to put the y-intercept or else we don't have an equation. So you have to kind of draw where that y-intercept would be, which is going to be 1. So x plus 1, where x is greater than or equal to 1. Okay. For the next one, it says, for the piecewise function, find the specified value, then graph the piecewise function. Okay. So this first part, f of 2, we need to use, so there's two different functions. If x is less than 0, it's just -2. All right, I'm going to need somebody to watch this video and come help me learn how to use my computer. I don't know how to stop touching the keyboard piece. Okay. So f of 2 is this first one, where x is greater than or equal to 0, and that means it's just -4. Any number, if x is greater than or equal to 0, is going to be -4. For x, this one, f of -2, is where x is less than 0. So then we're going to have to put it into the function. So it's going to be -2 minus -2, which is just going to be 0. Double check my mental math. Okay. Now we're going to graph it. So where x is greater than or equal to 0, it's just always going to be -4. So here, and then it's just going to be a line a flat line just like that. And the other one is going to be, the y-intercept is going to be -2, and it's open, and then it's a -1 to 1, so it's just like that. Yep. And that should be that piecewise function. Okay. All right, so describing a graph, we have find any relative maxima and relative minima of this function. So we have anywhere we have a maxima or a minima is going to be where it changes direction. So if you have a minimum, it's going to be decreasing, but then it's going to be increasing. So where it changes from decreasing to increasing, that's a minimum. If you have something that's, something that's increasing and then decreasing, then you have a maximum, okay? So here we have a minimum at -5, right? When x is -2. Okay, so the point would be -2 comma -5. And oops, that was the minimum. Sorry, I know you're yelling at me. I know you'll tell Mr. Brown I messed my video up. This minimum is, the minimum is -5 at x is -2. Son of a mother. Okay, and the maximum goes all the way up to -1 when x is 0. So where is the graph increasing or decreasing? So here we're going to want a domain of where this is increasing or decreasing. So it's only increasing in this little spot from -2 to 0. Okay, so that's going to be the easy one. From -2 to 0, it's increasing. It's decreasing at two different spots. It's decreasing from -infinity to -2. Union with 0, should be a capital, union 0 to +infinity. For the pair of functions here, we need to do, wonder if I should just make a video for composition. I'll just do it on this one and then stop after this one. And then we'll do transformations. For the pair of functions f of x equals 3x squared minus 2 and g of x equals this, find the following. So if we add them together, of g of 6, okay, so we're adding them together and then we're going to make it 6. So 3x squared minus 2, there's my f, plus x minus 2, there's my g. If we simplify it, we'll get 3x squared plus x minus 4. Now we need to make the x 6. Okay, so 6 squared is 36 times 3. Oh, geez. 36 times 3, 18, carry 1, 9, 10, 108. Plus 6, well, 6 minus 4 is 2, so 108 plus 2 should be 110. So first I just added f and g together, and then I substituted in 6 for x, and that's how I did that problem. Okay, now we're going to multiply, but this time we're just going to use x. So all we have to do is we're just going to simplify it. So quite honestly, on the test, if you just put 3x squared minus 2 times x minus 2, I'm going to accept this, okay? Don't forget f times g of x equals. Or you could go ahead and multiply those out. So if you use an area model, x minus 2 times 3x squared minus 2 is going to give you 3x cubed minus 6x squared minus 2x plus 4. So if you did simplify that out, that's what you would get. 3x squared, 3x cubed Sorry. I think Omar's the one that says that I say something and then write something else. 3x cubed minus 6x squared minus 2x plus 4. But it's the same thing. I'm more than happy to have you leave it just by putting them in parentheses and multiplying them together. Now we're going to get into the composition of functions, which is different than multiplying. So this one, okay, we have g of f of 4. All right, so first of all, let's do g of f. Okay. So we can write that as, if we write our g, it would be x minus 2. But it wants us to put the f where the x is, the entire thing. So we would have 3x squared minus 2 minus 2. Okay. So now we're going to put in the 4 where the x is. So it is just going to be, and this is just almost like adding them, but a little bit different. 3 times 4 squared, and then minus 2 is going to be minus 4. So 4 squared is 16 times 3, I think is 48, minus 4 equals 44. Okay. And now f of g of just x. So we take f of g, so we're going to write f. But instead of writing an x, I left a really big space because inside there, that's where I'm going to put my g. And I'm just going to keep it like this. This is perfectly acceptable. This looks like vertex form of a quadratic. So let's go over vertex form really quick. So this is going to be g, or f of g of x. Vertex form means that a times x minus h squared plus k. So vertex form, obviously, because I can see my vertex. My vertex of this one is going to be positive 2 and negative 2. It's always going to be the same there, and it's always going to be the opposite of what it is there. Because remember, when we're shifting functions, this minus 2 means we actually go positive 2. That's going to come in handy later, I think. All right, I'm going to skip this transformation and go back to it. And let's see if we can keep with either looking at graphs or doing compositions. It's average rate of change. Oh, here is one. If a function f is increasing on the interval from a to b and decreasing from b to c, so if we have an interval that is a, b, c, and it is increasing from a to b and decreasing from b to c, what can be said? Well, we can say that that is a maximum. Okay, determine the intervals which is increasing or decreasing. Okay, so same thing here. This time we have, I'm glad I just went over that, we're going to leave. Here, just really quickly, the vertex of this is going to be negative 3, negative 2. So the intervals on which it is increasing and decreasing, this is a positive parabola, okay? And it's going to, here it's going to be negative 3, negative 2. So it's going to decrease from negative infinity to negative 3 and increase from negative 3 to positive infinity. And just write that in interval notation because my video is about to end.